I am here to talk to you about some things that I've been working on at Cordoba. We are a startup based here in San Francisco, not too far from here. And just by means of introduction, there we go. So at Cordoba, I'm head of data science, and most of this presentation will be about what I'm doing there. Okay. And I also wanted to give you a little bit of background as to why I'm at Cordoba, why I'm working on what I am working on. Prior to joining this startup, I was at another startup based in San Francisco called Itibon, and that was basically all NLP all the time. And much of what I learned there is very relevant to what I'm doing with Cordoba. And the reason that I really love NLP is because it combines two areas that I'm very interested in. Both of my degrees are in computer science, so I really like the coding aspect. And when I was a teenager, I decided to learn another language. I lived overseas for a few years, and it's a language that I'm still fluent in, that I still use on a daily basis. And computational linguistics really helps me to combine those two things that I really love. So I get to do a lot of that at Cordoba. And obviously distributed systems, the reason why I'm here is because you can do a lot more with NLP if you have a lot of machines to do it with. And I also gained an appreciation for emoji. You'll see a lot of emoji in this presentation. And quick bio, I've been working with language technologies for a few years, so I'm pretty sure that most of my friends think I'm working on a universal translator, which would be really cool, but it's not what I'm doing. Obviously, I'm saving the world on a daily basis. No, we'll talk today about what I am actually doing. So to summarize, the point of this talk is really to go into detail about how we are solving the problem of helping companies release products that feel native to every user, regardless of what their language is. And we're using machine learning to make that so easy that the default is when you release a product that it gets released into multiple domains simultaneously. And, spoiler alert, it involves a lot of open source. We really think that there's a better way to do internationalization than the traditional way. And I'll give you that sort of larger picture of what internationalization is and why it's so difficult. And then I'll talk to you about specifically the project that I've been working on, which is very NLP focused, and we'll talk about my contributions to the platform. So what is Cordoba? You can sort of think of it as the Docker of content. The way we are trying to automate everything is by pulling out content into its own layer. Very similar to the way Docker pulls out a lot of the deployment specifics. So if you think about the bottom layer of the stack is your infrastructure layer, and that's your machine image, that's your bare metal. On top of that, you have your Docker containers, and that's what you use to deploy your application. And then a layer above that, you have your actual application. That's your code, that's the thing, that's your core competency, that's what drives your business. And then the layer on top of that is your content layer. And by extricating that into its own separate layer, that makes it a lot easier to change it up, to make it really independent of your core application logic. And you can do a lot more with it if it's completely separate. So what does localization look like today? It's a field that really hasn't changed a whole lot in the last 30 years. There's a lot of tradition associated with it, and it involves a lot of people. There are a lot of bottlenecks in the process, and that's mainly around humans communicating with each other, how they're doing it, what they're sending to each other. It's a lot of string files moving around, emails, phone calls, requests, asking for favors. Lots of these types of things, misunderstandings between linguists. There are a lot of problems with it. And we've all seen the results of this. If you're familiar with the Got Milk campaign from the 90s, it was wildly successful in the US. The American Dairy Farmers Association, they had this campaign that was so successful that they wanted to release it into other markets. And so there's the Spanish version of that ad ended up translating into something roughly equivalent to, "Are you lactating?" which I'm sure did not help them sell any milk. And I have an example here that I want you to think about. If you were going to localize this content, how would you do it? This is a really effective ad. This is a company, I believe they're a fashion company that's selling these cell phone covers. And this ad really speaks to you immediately in English. It's pretty great on a lot of different levels, but if you were to translate that into German, what would that look like? It's really tied in to a lot of very specific cultural references. It's a quote from a song. How do you translate quotes from songs? It's okay if you don't know German. The rough translation is, I realize that when this telephone service flashes, it can only mean one thing, and that is a lot less effective. It doesn't have that immediate impact that the English version has. So that's one example of why localization can be so hard, because you're not just doing that in one language, you're doing that in a lot of different languages. And you might also, I believe the talk before mentioned the effectiveness of ads for different age groups. And this might be very effective on a younger age group, less so for a generation that hasn't listened to that type of music before. So we think that there's a better way. We think that there are a lot of problems with the traditional approach, and we have a lot of ideas about how a lot of that friction can be reduced. So how do we go about that? We built a platform, and it supports a lot of it supports a lot of modifications to that process. It seeks to reduce that human-to-human contact. It seeks to reduce a lot of the friction between teams. When you localize a product, you're involving marketing, you're involving engineers, people who don't traditionally work all that well together. And by separating content out into its own layer, you're pointing to a link in the cloud so that once you deploy your product, you can change what's behind that link, and you get live updates without having to redeploy your software. And that also gives you consistency among mediums. So if you have published a website that's pointing at something, that means you can also publish a mobile app that points at that exact piece of content. And when you change one thing, then it's reflected across every product in your suite, your printed materials, everything. So that also gives you the benefit of having real-time translations. As soon as you're generating content, because these are links, you can have translations immediately. So you can deploy things right away without having to update your code or redeploy it. And the other big thing, this is my absolute favorite part of the platform, is the GitHub integration. I have an engineering background, and having requests come through as a PR is the #1 best way for a marketer to communicate with the engineering team. So a marketer just has to use the website, and Cordova takes care of generating the PR, and the engineers really don't have to care what's inside there, because it's just text, it's images, it's video, it's stuff that's not going to break the platform. And because it's in its own layer, a marketer can request it as much as she wants, and then it just gets deployed whenever is convenient for the engineering team. The other #1 biggest problem, I was talking to a company a few weeks ago, and I asked the head, I believe he was the head of the data science side of their localization team, and I asked him what his #1 problem was, and he said context, because his people were emailing screenshots between one another, and things were getting lost. And it's really difficult for a linguist to just have a spreadsheet with text on it. But if with this platform, you have a live editor, and you can change things in the middle of the page. So on that Hotline Bling page, you know exactly the length of the string that you need. You can adjust the design, and you really understand what the product is that you're selling. Instead of just seeing the text, how would you translate that? So context is really important. Okay, so those are core features. Those are some of the biggest bottlenecks, some of the biggest problems that we've solved. I want to go over an example. So I want to put this in terms that should be familiar to everyone here. And this is Dolores Park. This is in my neighborhood. This is a pretty typical day in the Mission in San Francisco. And let's say I am a produce vendor. It's a beautiful sunny day, and I want all these people to buy my watermelon. So let's say I'm in Perfect Produce, and I come up with this beautiful ad that I think will be really effective. So I go to an electronic billboards company, and I give them my beautiful image, and I say, hey, I would like for you to deploy this on this billboard in this location. No problem. They press a couple keys. They deploy it. It's really effective. You sell a ton of watermelon. And so since that's successful, you want to deploy that same image across town, in Chinatown. It's a place that you're familiar with. You think that you could also sell a lot of watermelon there. And you deploy it, and you don't see that same bump in sales. Why? Your electronic billboard company isn't going to come back and tell you maybe you should change something. That's sort of up to you to decide on the content that gets deployed. You still own that content and you're still responsible for it, but they're the ones who are actually doing the deployment. So what can you do? You can change that image. It's clearly not effective, so you either pull it entirely or you change it. So is anyone familiar with this story of Brother Orange? It's a really long and hilariously complicated story. I won't go into it, but it's these slides will be posted, so you can follow the link. I highly recommend it. But the point is that the story really references, it's this friendship between a Chinese person and an American person. And so that would be a really good spokesperson for imperfect produce in Chinatown. So what they decide to do is they have Brother Orange tell people to buy their produce. And they see a huge bump in sales. It's really effective. They're selling oranges, not watermelons, but who cares? So how do you, if you were to do this, so you have two really effective campaigns in two very different markets within the same city. How would you maintain that? The billboard company isn't going to do it for you, and you still have to come up with images and text. And so that's where things can get really complicated. If you extrapolate that out into different areas of San Francisco or across the Bay or even across the country, much less across the world, it can get really complicated. And I wanted to show that example because it really goes to show you that it's not about languages, it's not even about countries. It's about the different subcultures within languages. So it's not even really about physical location. We really see that content layer as having lots of little mini containers that are related to specific domains. So maybe there's a produce-specific domain. If you're writing an obituary, it would be completely inappropriate to be using text that you might find on social media. And so you really want these different domains. You want somber French, you want legal French, you want really lots of different containers. So this was our diagram. The whole point is separating content out into its own layer. So that's the larger picture. That's the business problem that we're trying to solve. And now, so this is getting into what I think is the most interesting part because it's the project that I've been working on. And how does this tie into that larger problem of globalization? What does affect detection have to do with automating a system to help you release products in many different markets? Well, if you think about, if you've ever sat down in your favorite Chinese restaurant, looked at the menu and chuckled, you'll realize that there's a very visceral reaction. There's a very definite gut reaction. When you see something that's very clearly incorrect, you have a very different emotion than if it were just the correct translation that made perfect sense to you. So if it was perfect English, you wouldn't laugh. If it was something a little bit funny, you'd kind of chuckle at it. So emotion can be a very important signal as to the correctness of a translation. And if we're automating a lot of this, we want to have as much signal as possible. We want to understand how good our translations are because we're building models and we're redoing them all the time. And so affect can give you one signal, and it can help you flag things as incorrect translations or translations that maybe someone should look at again. I also should have defined affect detection. It's cool if you don't recognize it. It's kind of, it's an academic term, and it's essentially just identifying the emotion that's associated with a piece of text. So it helps us with automating things, and it helps us when we transition through those workflows, when it goes from marketing to design to engineering, it can flag things as, hey, you might want to look at this. These emotions don't match up. This translation might not be quite right. A couple of examples of this. These are all sentences that we put through our affect detector. And this first one, what would you imagine, what kind of emotion might be associated with this sentence? Your choices are, I don't know, joy, anger, sadness, fear. What would you expect to be associated with this sentence? Does anyone have a wife? What do you normally feel when you get to dinner with her? Okay, I won't wait for answers. So the emotion that was associated with the predicted emotion was fear, which is very interesting. You know, this is trained on a corpus of data. This tells us something about the corpus that we trained it on. I wanted to say culture, but the next sentence that we sent in, we changed one word. We didn't even change the gender. But we got a very different result, and that's a really good example of very small tweaks in the language that can have very different meanings. This next example, let's say I'm in the mission, I'm with Imperfect Produce, I've been selling all of this watermelon, and I can't handle the capacity because my Chinatown business is also doing really well. So I put up this sign, help wanted, I need some people to help deliver my fruit, and so that would essentially convey maybe I'm overwhelmed or, hey, I need someone to help me out here. But I'm in the mission, and so I think that it might be a bit more effective if I add a Spanish translation to that. So this is the translation that I come up with, which is roughly equivalent to get off your lazy ass and get a job, which has a much different emotion associated with it, and I am much less likely to get a Spanish-speaking person to respond to that ad. The other one, so I really like this one because it's an actual example. So I mentioned that I live in the mission. My rent is outrageous, and the best way to make ends meet is to put up my apartment on a vacation rental site. Now, I mentioned that I spent some time in Germany. Oh, well, let me tell you the emotion. So this is very clearly like, it's a killer location. It really is. It's on Valencia. It's amazing, and I get a lot of Americans that come to stay with me. But I mentioned that I that I lived overseas for a few years. The language that I decided to learn was German, and so what I really want is not for Americans to come stay with me. I really want Germans to come stay with me because I want to keep up my skills. I want to sort of stay connected with this decade-old trip that I had where I lived there for a few years. So what I really want is Germans to come, so I make sure that I have a German translation. And so I think it'll be pretty clear. Diese Wohnung befindet sich an einem mörderischen Standort. Mörderisch, that's the equivalent word to killer, which essentially means this apartment is in a murderous location. And that means that Germans are not going to come stay with me. So that's a really important piece that I'm just not going to accomplish my goals with that. So this is why affect detection can be very important. Most of the time it should be very similar, but that one translation could mean the difference between me maintaining my language proficiency and not. So this was my task. I wanted to build an affect detector to put into the product. So the larger platform already had a lot of the machine translation working, and really all I cared about was this affect detection portion. So all I wanted was a service that would be able to train models, that would be able to take a piece of text and return an emotion, and it had to be accurate. Accuracy is really important. We don't want a lot of false positives. It doesn't have to be perfect, but it does need to be pretty close. So because the rest of the platform is built on a pattern of microservices, it needs to have a REST interface. The rest of the platform needs to be able to call it, and it needs to be really fast. Everything we run is in the cloud. We're a typical startup. And it has to be scalable because obviously we're going to make it big and we're going to have a ton of customers, and we're just going to, every startup has a scalability problem, so we don't want to deal with that. We want to make it scalable from the beginning. And it needs to scale not just in terms of the languages that it supports, but it also has to scale in terms of deployment. Can we throw more machines at it and will it fall over? Can we add more models to it? All of those containers that we talked about, there's essentially an infinite number of these domains that we could add. We want it to be we don't want to be constrained by the model that we choose. And the other thing that was really important to us is the fact that it's open source. We really wanted to use open source tools because it's something that we think is important. We think that the thing about NLP is that there are so many. I'm building an affect detector, and that is very applicable to this one situation, but there are so many pieces within that affect detector that are also applicable to a lot of other NLP problems. As an example, a tokenizer. There are a lot of English tokenizers, and they're pretty good, but if you've ever looked for an Arabic tokenizer, you'll be bitterly disappointed. And so we support all the languages. We have an Arabic tokenizer. One of our co-founders, I believe that's his native language, and it's really, really good. We don't want to just hoard that. That's really important to let other people use because it will help us accomplish our mission even if we're not the ones doing it. So this is what I set out to do. This was my task. And I mentioned that I was at Idibon previously. We had this big, huge, fancy NLP system. It was amazing. That's what I was used to using. But I didn't have access to it anymore. It wasn't running. And so I had to come up with something from scratch. I had to come up with something that I could use for my purposes. The good news is that I was on the engineering team, so I knew how it worked. I knew what was behind the scenes. And I knew that I didn't need all those bells and whistles. I needed something very, very specific. So the good news is that Christmas came early for me. Prediction.io entered Apache Incubator status, which meant that I had this sort of ready-made framework that I could immediately use. I picked it up, and within 2 days, I was getting emotions. I was able to build something that would spit out emotions. And granted, they were on Simpsons quotes, so they weren't directly relevant, but it was something, and that was a lot more than I could do by building the entire thing from scratch. So the great thing about that is that I didn't have to build up an open source community on my own. I had this ready-made one, and it had all of the things that I needed. It was fast, it was scalable, it had that REST interface. And once I went through that code, once I looked at the objects that I would be using to build my models, I really liked it. You know, having tried to build this on my own, it was like being in an episode of Blue's Clues where the salt is called Mrs. Salt, the pepper is Mr. Pepper. And the naming convention that they use and the dependencies between those objects are beautiful. It's just very clean. It's not perfect, but it's pretty great. So instead of operating in the top half of this diagram, I was able to very quickly ramp up to like stage 3 and spit out emotions and have something that was usable within the product very quickly. So what does that bicycle look like? Is anyone familiar with this scene from Apollo 13 where Tom Hanks is stuck and they lock all the rocket scientists into a room and they tell them, you need to save this man's life and these are the things you have to do it with? Well, it felt a little bit like that because there are a lot of components. The Prediction.io framework, the cool thing about it is that it's scalable. But how is it scalable? It's scalable because it gives you a lot of flexibility. It decouples the storage and compute layer. So you can use really any, well, it doesn't support everything, but you can use a large variety of storage systems, and you can scale those out independently. It supports HBase, a ton of different things. We chose to use Maria. And the reason I really like Maria is because it kind of gives you the best of both worlds in terms of relational and NoSQL capabilities. You can define tables within your Maria database that reference tables in your Cassandra cluster. And so you can do very interesting things by having those in the same place. And for the compute component, it uses Spark under the covers. Prediction.io doesn't work without Spark. You have to have it. But you can choose to run it either in local mode or on a separate cluster. You can connect it to your existing Spark cluster. You can build a standalone one. It's kind of up to you. We chose to run that in Kubernetes. And the main image, that middle part right there, that's the sort of core of your application. That's the core of your machine learning models. That's sort of everything that's involved in the platform that's not compute and storage. And it's really tidy in that way, is that you do everything in that one machine image, and then you just sort of farm it out to your storage and compute. So I wanted to take a little bit of time to go into some of the basics of NLP. Raise your hand if you would be super bored if I went over like what these terms mean. If you really don't want me to, I can totally skip over it. But I find this useful for people who are maybe very new to NLP. So anyone? Speak now or forever hold your peace. Cool. So I'll try and distill this down to a very simple explanation. The whole point of natural language processing is to take text data and turn it into numbers, because once you turn it into numbers, you can use mathematical models to do something useful with it. So you want to be very clever about how you turn that into numbers, because that will determine the types of models that you can use. But that's essentially it. It's using math to automatically figure things out about text without having to have a human look at it. So these are the main components of that. The very first step is your feature extraction, and that's where you turn it from text into numbers. And the next step after that is your training component, and that's where you take your mathematical model and you use your data set to fit coefficients. And that just gives you a means of, it's kind of like having an answer key and using that to build a formula that you can then use to figure out, to solve for x, essentially. When you have a different piece of text, you can use that formula to figure out what the emotion is, or whatever it is you're trying to figure out. After you do your training, that's where you build your models and you specify exactly which type of mathematical model you're using. And once you've done that, that's when you can do your prediction. That's when you have your formula, you fit your coefficients, and you can send it a new piece of text that it's never seen before, and it can give you its best guess. Once you've done that, you always want to test the accuracy of your predictions. That's the cross-validation phase, and that's where you build lots of different models using that same training data. You split it up into lots of different pieces, and you build, standard is tenfold cross-validation. You essentially train 10 different models and look at sort of an average of its performance. And that will give you an idea of how good your predictions are. And usually the results are terrible, so you end up going around in this loop several times until you get what you want. The hyperparameter tuning phase refers to changing different parameters with your mathematical model in order to get slightly different results. Those parameters can be very important in the results that you see. So quick explanation of the featurization stage, feature extraction. Just in a little bit more detail, the first step is to take your text. It may be something from DataSift or Twitter or wherever, from GNIP, and it may have a ton of metadata. So first step, you take out the piece of text that you care about, the data that might be relevant, like geographical location, whatever that might be, and you break that up into pieces. That's the tokenization step that I mentioned earlier. And once you've tokenized it, then you want to look at the most common tokens in there, or the most commonly occurring neighbor tokens. Those are your unigrams and your bigrams. And you essentially put those into a vector. And there are different ways of doing that, but the simplest way is just to look at how often they occur and assign them an arbitrary index and count them up and create a vector out of it. So that's what that vector represents. And that's a Spark vector. That's the native BLAST representation. It's literally a vector of doubles. And from there, this is where you add your label. This is your answer key. This is the training phase. So you add your classification. That's that extra 1 off to the side. So it's a vector with a label attached to it. And you take your pick of any algorithm. There are a bunch of different classification algorithms to choose from in MLlib. And you essentially call a function. You give it that vector, that's a labeled point data object, and you let it do its magic, and it will spit out a model. And that's the model that you would deploy in order to get your predictions. So in that prediction phase, you have this new piece of text, and you need to featurize it in the exact same way that you did on your training data. So that's this diagram at the top. That's the exact same featurization pipeline that we saw on the earlier slide. And we featurize it, so turn it into numbers, and then send it into our mathematical model. We send it to Spark, to MLlib. And we get an emotion. So pretty simple. And what we do with that emotion is, kind of up to you, but hopefully you're doing something useful. Cross-validation is the thing that we talked about where you're evaluating the performance of your models. You're looking at the prediction, how accurate your prediction is, and you usually split up your training set into maybe a 70-30 split. So 70% is what you use to train your models, and the other 30% would be what you use to evaluate it on. And you would do that random split a number of times, usually 10 times, and then look at your F-score. And that will give you a hint as to how accurate it is. So this is what it looks like specifically in prediction.io. The terms at the bottom, the data source, the preparator, the algorithm, and the serving, those are those Blue's Clues names that I was talking about. They're really obvious, very clean, and the featurization step, that's at the preparator phase. If you're familiar with the prediction.io framework, that's sort of that's the correlation between the two. So that bicycle, let's get back to what that bicycle looks like. Really simple. We've already gone over this chart, but it supports every language, so that automatically means UTF-8. And we're looking at term frequencies, so not even doing anything super fancy, looking at n-grams. And this is a really important stage, so it's definitely somewhere where we could make a lot of changes and have a very high impact. The training phase, in prediction.io, it's just called an algorithm, and that's where you call Spark MLlib. And for us, that's a supervised model. We're using logistic regression, and we're doing multi-class classification. So we're essentially treating the emotion problem as multi-class classification. Very, very simple, really classic problem. And the thing that I really like about the training that we're using is we're using these YouTube videos to generate our answer key. We're taking YouTube videos that have transcripts attached to them. They also have timeframes associated with them. So we can extract frames from those videos, and we have the corresponding text. And so depending on how you sample those video frames, you have a different number of images, but we send off those images to the Google Vision API, and because that can recognize from a face the corresponding emotion. So now we have the text that's associated with the picture, and we have the emotion that's associated with the picture, which gives us the link text to emotion. So we're essentially using someone else's supervised model to bootstrap our own model. And this isn't, it's not going to be super clean, but it's a great place to start. And the more we use the models, the more information we get, and the more, the better they can get. But this is how we started, and I really love this approach because it's really kind of getting creative. And let's see, so the prediction phase, this is prediction.io's serving component. And for us, this is very simple. It goes through that same featureization pipeline, and then we have sort of a router in front of the prediction.io deployed model. And that allows us to specify a language. We deploy one model per container, so per language or per domain. And having a router in front of it just means that any other part of the application can specify, I want this model, and this is the text. We also support events. So we will probably end up migrating a lot of it to PubSub, but for now we support both. And cross-validation involves all three of these objects. Actually, there's a third one called evaluator that I don't have on this slide. But cross-validation, we've already talked about this. It looks at the F-score, and it can just help you understand how close you are. So this is sort of the next generation. What will that next step look like for us? What does the motorcycle stage look like? Well, we have a ton of ideas, and there's a lot we could do. I've presented the very simple iteration of these things in favor of being able to explain it well. But for featureization, just Google it. There are so many different approaches you can take. We also don't necessarily need to treat it as a raw multi-class classification problem. We could treat it as a series of binary classifications. And we can use that to generate confidence scores. Right now, we're just sort of spitting out one label, but it would be helpful to understand if another emotion were very closely tied to the primary one. Confidence scores would really help with that. Different types of classification algorithms, random forest, it's a no-brainer. Definitely want to add that to it. And we want it to automatically try different types and give us the best one. We want to be looking at more things. Obviously, we want to automate as much of this as possible so that you don't have a data scientist sitting there in that sort of head desk loop going through things over and over again. And another interesting way of looking at this is instead of seeing it as a classification problem is maybe looking at it as a graph problem. Because emotions can often be very closely related to each other, if we have those confidence scores, we can sort of map things on a relationship space, and that might fit better into a graph problem rather than just a strict classification problem. We also want to obviously use things other than English. We want to expand it to every language that we have, and that means getting training data other than just the YouTube videos, because that doesn't support, there aren't enough videos with transcripts that we can use. So I think just last week at Next, the Google Cloud conference, they announced this video intelligence thing, which is really cool. It allows you to, it's some sort of video search capability within, I guess it's YouTube. But that spits out emotion as well, so that's something that we could certainly utilize. And I believe there's a detect faces thing that does something similar, which would tell you whether a person was smiling, which might be associated with specific emotions. And also, neural nets makes a lot of sense. That might be a component of the affect detector that would give us some extra information. I'm not sure if we would want to just throw out all the supervised stuff we've done, but it would be worth looking into, and then obviously generalizing this so that we're not only looking at emotions, but we're looking at really any type of classification. It doesn't, all of this stuff is applicable to anything besides just emotions. I think we're running out of time, so I won't go into too much depth here, but this is what our stack looks like. These are the tools that we're using, and we're still a fairly new company. We've been around for a few years, and we were able to choose very modern tools when we started building everything, but we're also iterating on that. We're seeing what works and what doesn't. And I think the most obvious thing, we've sort of migrated from Mesos to Kubernetes. We're still kind of in the process of seeing which one works the best, but I built most of the affect detector in Kubernetes, and it's been a really smooth transition, and so we're looking at moving the rest of the stack onto that too. Like there's some really exciting things in our tech stack, and we're definitely evolving every day and evaluating new stuff that comes out as new APIs come out. So that was about all I had. If I could leave you with one thing, it's just that there's a better way to do internationalization. So don't limit yourself to just phone calls and emails. And if I could get you excited about any type of NLP, it would be affect detection, because I think that's really useful and it's really kind of underappreciated in the space. So the next time someone asks you, what do you want to do tonight? You can tell them, affect detection, same thing we do every night. So if anyone has any questions, I don't think we have too much time, but a few is fine. Yeah, that's a great idea. The question was whether we could use movies with subtitles. And I think if we even just took out the images and did some OCR on it, I think that's a great way of doing it. That would absolutely be applicable. That's a great question. That's really hard to detect. I don't have a great answer for it, but I'm pretty sure we could mine Reddit for a lot of examples. Yeah, that's a tough one. Yeah, so the question is, wouldn't you have to really zoom out to understand sarcasm, not just looking at the specific segment or the specific website? You would really have to have the full context. That could definitely get complicated. And it would also be very important which medium, where did it come from, and what was it mobile, was it whatever? That's true. Anyone else? Okay, thank you.